Hello students. Okay, so this is going to be the introduction to quadratics. You have your packet of quadratics, so pull it out, have it ready, and remember you can pause this video while you get your materials ready. You will need the highlighters, so for this particular introduction to the topic, this is what I'm going to be checking for. Okay, highlighting. I need to see the highlighting. All right, remember, if I don't see the highlighting, it's a 0. You have to take also complete notes. You have to be logged on the Google Meet. All right, otherwise there's also no credit. And you have to also submit your notes, okay? At the end of the lesson, when you're done copying when you're done doing completing the notes, you have to submit your work, okay? Submit your work. All right? So this is now the beginning of a new topic, and this is the last topic that we cover before we start working on study guides. That way we can start ready for our test, okay? So this topic is about quadratics. And you're going to see now that this is a different type of graph. The quadratics, it's an equation that has this form, okay? This one right here is, let me box it. So remember, everything that I do, everything that I write, everything that I highlight, you're going to be doing with me, all right? So this right here is the standard form of the quadratics. Okay? There's the vertex form and there's the factor form of the quadratics, but we're not going to get into that. For our test, for our start test, we're going to talk about the standard form. Okay? All right. So you have an equation now that has an x to the power of 2. Now, all this time, since October, we've been working with linears, okay? So let me give you a background, okay? We've been working with linears. And now we're going to be working with quadratics. With linears, we analyzed and we worked with the slope-intercept form, y equals mx plus b. We also work with the standard form of the linears, which is the ax plus by equals c. All right. So linears is basically an equation and a graph of a line. All right. And the topic that we just covered was systems of equations, where we had systems of two lines, intersecting lines. So we work with one line and we work with two lines. Okay. So now it's the turn for quadratics. When you graph a quadratic equation, the graph is a parabola. It's like a letter U, but it's called a parabola. Okay? We're going to draw it right here. All right, so it is important that you have your highlighters ready. And look at me, I'm missing my pink highlighter. So make sure you have your highlighters ready with you, all right? If I don't see the highlighting, I'm sorry, but it is going to be a 0. Let's begin talking about this letter. If you see, this letter has a whole box for itself. So let's highlight the box. And it continues over here. All right. Highlight your box in yellow for this right here is going to be a number, any number. All right. Let me put any real number. any real number. Like a 1, a 2, a negative 1/2, a 1/2, 50, 100, okay? And you see these two examples right here. You have y equals 2x squared and y equals negative 2x squared. So, I want you to practice with your calculator. Let me delete all this. This is what we were doing with our systems of equations. Now we're going to go to the graphing button. But before I do that, let me make sure that I delete all documents. I don't believe I have any documents. We're going to use the graphing button right here. Oops, there we are. Okay, so look what happens if I graph this equation right here. Remember, even if you see the y equals, it means that this f of x, that's your y equals. So I'm going to type 2x squared, 2, and then for the x squared, we put the x, and we press this one right here, the x squared, okay? But you actually have to type the x first, x, and then squared. And that way you have your graph, all right? So what does this look like? You see, it looks like a letter U, like a capital U. So that's what we're going to do here, all right? We're going to sketch what we see. We see a letter U. Okay, we're going to represent it with arrowheads. We have the arrowheads there, and there's several elements that we have to look at here. First of all, where the graph changes direction, like if you see over here, if somebody was writing down a pipe in their skateboard, they go down here, this is the minimum point, and then start going up. This one right here is called, this point is the vertex. But just like in our, just like you see it in the pipe when you're skateboarding, is the minimum point. When you see people skateboarding, they start over here, they go down, they reach the minimum point, and they go back up again over here to the top. So this is also called the minimum. All right, the minimum. This one we say that the parabola is upward or up. And look what you see here. What do we see here? This one is positive. It's a positive parabola. Positive number. All right. Now let's grab this one. Let's see what this one looks like. We're going to start a new graph. Let's put it in here. This one is negative 2x. So, negative 2x squared. Right here. Enter. You see what happened to the parabola? Now it's down. So let's sketch it. This is what we see. Let me use my blue pen. We're going to sketch it here. Now, this parabola has the same image or the same shape as, for example, when you're riding a roller coaster. You go up the roller coaster, you reach a maximum point, and then you start coming back down. That's when we all scream. Or when you throw a ball up in the air, it reaches a maximum point and then comes back. Or maybe you also have seen all these videos of people that like jump in the water, you know, or like when they jump in the balloon and they, with all the impulse, they go and they get thrown somewhere else. So that is a trajectory in the form of a parabola. So same thing, the point where the parabola changes direction, this is also called the vertex. But contrary to this one, over here we say that we reach a maximum point. So that is also called a maximum. And we say that the parabola is downward because it's pointing down like this, okay? Downward is down. And because the coefficient A is negative. Negative A. Okay? So what happens if we graph both on the same graph? Let's put them here on the same graph. I can go back, I can use this one. I'm going to press tab and I'm going to graph, no, not this one. Let me go over here to this one right here. I'm going to press tab and I'm going to graph the negative one. Negative x squared. Enter. You see what we have? That way you can see the comparison. So let's draw them. This one is up. This one is down. Okay? That's what happens when we graph them both on the same graph. Both of them, for this one it's a minimum, for this one is a maximum. Oh, sorry, I covered it. This one is a maximum. So it's the same point, it's called the vertex. Don't forget, we're going to see this word a lot, the vertex. Now, this is a point, this is your x and y coordinate, okay? This is the y, this is the x. The vertex in these three examples is located at this coordinate, at 0, 0. Okay? Alright, so that is the beginning. What happens to the graph if this number is either positive, the graph is upward. If it's negative, the graph is downward. Now, what else are we going to continue talking about? What about, look at these two equations. We have 2x and over here we have 1/2 of x. Let's see the difference. Okay, we're going to graph them. I want you to see the difference. I'm going to graph the first one. Again, 2x squared. And we have a parabola like that. So let's draw it like this. Now, why are we just graphing this and not all this? Okay? Because what if b is a 0 and c is a 0, then these two terms become a 0 and then you only have this. And this one we call it the parent function. If a is a 1, then this is the parent function. Okay? So we're just working with the parent function with the different coefficient than 1. Alright, so this is our first graph. Now let's press tab and graph this one right here. 1/2 of x squared. Control divide. 1 over 2 x squared. Enter. What's the difference between these two parabolas? Can you see it? This one, I don't know if you can see the colors. The pink one is narrower than this one over here. This one is actually green. I don't know if you can see the green, but this one is wider. So that's the difference if you have a big number or a small number. So let's draw them over here. I'm just going to exaggerate that this one is wider. Remember, as you watch the video, you're taking the notes with me. This one is wider. This one is narrower. So, what can we say about this? What can we say about quadratic equations? If the a is a positive, if the number at the beginning is a positive or a negative, if it's a positive, it's facing upward. If it's a negative, it's facing downward. How can we describe this? We're going to write it like this. Bigger numbers, the parabola is narrower. If it's a smaller number, because this is 2 and this is 1/2, 0.5. So we're going to say that smaller numbers then the parabola is wider. Okay, that's the difference. So bigger number, like the 2, the parabola is narrower. Smaller numbers, like 1/2, the parabola is wider. So remember, bigger number, for example, 3 versus 1/3, 5 versus 1/5. Because if you think of these numbers in the number line, which numbers are bigger? We're talking about, for example, 1, 2, 3, 1, 2, 3. Bigger number on the number line, 1/2. This is a 2. This is 1/2. This is a 3. This will be 1/3. Okay, so you see the values, how these are smaller numbers and these are bigger numbers. So when you're comparing two graphs, you have to look at which has a bigger number, which has a smaller number. And you have to, it's always the number that is in front of the x squared. When we were doing linears, it was this number will determine the slope. So it's very similar, it's just that this is not a line, this is a curve, okay? But it acts like the slope, all right? So all of these are the elements and the characteristics of your parabola or of the standard equation. Sorry, let me zoom out. All of these that we highlighted in yellow are the properties of the quadratic equation or function based on this little number here in front of the x, okay? Remember, what happens if the a is a 1? Then you just have what? If it's a 1, you have 1x squared. It means that it can be just x squared, all right? Now, let's talk about this little number right here. It's represented with letter C. We're going to highlight it. And if you remember in linears, we had a number over here in the equation that was by itself. A number that was by itself. For example, 3x plus 5. That 5 that was by itself, that number told us the y-intercept. The same thing is going to happen here. This number that is by itself, and you know what? Remember that we highlight including the sign. Okay, so go ahead including the sign. So we're going to box this in pink because these are going to be the properties of the y-intercept. Okay, so just like in linears, the y-intercept in the vocabulary, what did we say when we do the vocabulary for the y-intercept? It's the crossing the y-axis. So it's when the graph, let's draw it over here, right here, crossing the y-axis. And look at the coordinate. It is going to be the same as we do in the vocabulary for linears. It's going to be 0, comma, and a number. So highlight this, and highlight this. Crossing the y-axis. That's where the parabola crosses the y-axis. But if we have a parent function, for example, look what it says right here. Graph y equals x squared plus 2 and y equals x squared minus 3. Go ahead and graph it. Let's graph it over here. Let's go to a new graph. Let's graph the first one. Remember, the y equals is the f of x. We have x squared plus 2. Enter. Look at where the graph is. Let me zoom in. Look at where the graph is crossing the y-axis. It's crossing at 1, 2. It's crossing at 2. So let's draw that in our paper right here. We have 1, 2. 1, 2. And the parabola passes through here. Okay, this is the y-axis, this is the x-axis. This one right here represents the quadratic equation y equals x squared plus 2. Now, it says that we also have to graph this one. We're going to graph them on the same graph. Tab, x squared minus 3. X squared minus 3. Enter. You see now where the graph is crossing the y-axis? It's crossing the y-axis at 1, 2, negative 3. At negative 3. So let's draw it over here. 1, 2, 3. This is the negative 3. And it's also facing upward because this number right here is positive. So let's draw it over here. We can draw it like this. And like this. Okay? Doesn't matter if it looks like it's wider than the other one. What is important is that we see that this one is passing through, is crossing the y-axis at 2, and this one is crossing the y-axis at negative 3. So let's label the two graphs. This one is y equals x squared minus 3. Remember guys, we're just describing, we're learning the properties of the quadratic function, of the quadratics. Alright? And we're analyzing these two elements. What does this element mean? What does this element mean? Alright? All you have to do is copy the notes, but do pay attention, okay guys? Just because you're watching the video doesn't mean that you don't have to pay attention. You have to understand this. We will start working with these exercises on Monday. So this is where the graph crosses the y-axis. This is your y-intercept. Y-intercept here. Y-intercept here. Which happens to be also what? The vertex. But not all the time the vertex is going to be the y-intercept. Sometimes the y-intercept is going to be another point different from the vertex. Okay? Alright. So on this one, I also want you to highlight the y-axis. That way you can remember that we're crossing the y-axis. And I want you to highlight this number that is by itself. You see? Positive 2 is crossing at positive 2. Minus 3 is crossing at negative 3. Okay? Alright. Remember guys, you can pause the video to take your notes. I'm going to move on to the x-intercepts. Now, I know that with linears, we always use yellow for the x-intercepts. So I'm going to highlight the title. I'm going to box it in green. But remember, just because in linears we always used the yellow for the x-intercepts. So I am going to continue using the yellow for the x-intercepts. I should have used green over here. Alright, what can we say about the x-intercepts of a parabola? The x-intercepts, we're going to use the same vocabulary that we used for the linears. X-intercept means crossing the x-axis. It means that is going to be located, what is the coordinate? At number, comma, 0. There were three words, if you remember. Zero root solution, same meaning. Zero root solution. Okay? And I want you to highlight this, and this. And there's going to be three types of x-intercepts, or three types of graphs in relation to the x-intercepts. Look at this. It says no solution, one solution, two solutions. This has nothing to do with systems of equations. When we are finding the solutions of a quadratic function, we say that it can have no solutions. When you have a graph or a quadratic function that has no solutions, it means that your parabola is going to look something like this or something like this. Okay? If it has one solution, it means that the parabola is maybe located here and it's touching the x-axis. So we need to highlight the x-axis because we're talking about the x-intercepts. Over here. Right? Two solutions. When does a quadratic function has two solutions? When the parabola crosses the x-axis at 2 points, like this one. You see? It's crossing the x-axis at 2 points. It can be like this, or it can be like this. These are just different forms of the quadratic graph. If it crosses the x-axis at 2 points, it means that we have two solutions. If it only crosses the x-axis, this is one graph, it only crosses the x-axis at 1 point, it means we say that we only have one solution. If it never crosses the x-axis, we say that we have a quadratic function that has no solution. So this is what we say for this one. Never crosses the x-axis. This one we say that crosses the x-axis only once. This one we say that it crosses the x-axis twice. Okay, so write it down. Alright, I'm going to pause this video and then this will be part 1 of the video and then we'll move on and do the second part, okay? So I'm just going to pause it and then you move on to video number 2.